Hey everybody, so here is another video representing the area model for multiplication. The difference between this video and the last is that I'm going to be doing a 4-digit by 1-digit multiplication problem. Again, the strategy is going to be exactly the same. I am just using different numbers. So my problem is 1,436 times 7. Again, I'm going to draw a rectangle to represent this problem. I know that 1,436 is much larger than 7. So one side of my rectangle is going to be a great deal larger or longer than the other side. Again, it's not perfectly to scale, but it's evident that 1,436 is larger than 7. I like to write the dimensions of the rectangle down here. So the larger side is 1,436, and then the smaller side is 7. Now I need to know that in the number 1,436, this 1 doesn't really mean 1. It actually means 1,000. So I'm going to break apart this rectangle into some pieces. This first piece is going to have the dimension of 1,000, and I'm just breaking down the place values. The 4 doesn't really mean 4, well, it really means 400, so the next piece is going to have a dimension of 400. And then back to the number, that 3 doesn't really mean 3, it actually means 30. And then the 6, in fact, does mean 6. Now I've broken down my rectangle, and I can see the dimensions of each rectangle. The students aren't expected to color in anything when they use this strategy. However, I'm going to, in this tutorial, just to make it a little bit easier to explain. So I'm just going to shade in the smaller rectangles on this array with different colors. So we'll call that the orange rectangle. We'll call this the blue. Call this the yellow. And the last one we'll do purple. Okay. All right, so now I'm going to look at that orange rectangle, and I can see that the dimensions of that are 1,007. So I'm simply going to multiply those two numbers together. 1,000 times 7 equals 7,000. So the area of the orange rectangle, therefore, is 7,000. Now looking at the blue rectangle, I know that this side is 400, and I know that this side is 7 because it's the same length as the opposite end of the orange rectangle, which is 7. So the blue rectangle has dimensions of 407, so 400 times 7. That might be a hard problem for a lot of 4th graders to think about. 400 is a big number. What I can think about is, what is 4 times 7? I know 4 times 7 is 28, and then you can just sort of tack on those two zeros from the 400 to your answer. So 400 times 7 is 2,800. Looking at the yellow rectangle, I know this again is a dimension of 30 times 7. And I can use that same strategy that I used before with the zeros. I know 3 times 7 is 21, and then I can add the 0 from the 30 onto my answer. So the area of the yellow rectangle is 210. And finally, the purple rectangle is a 6 by 7. That's one of my facts that I know. 6 times 7 is 42. And now my final step is to add up all of the areas of the rectangles. So I can do that on the side. 7,000 plus 2,800 plus 210 plus 42. Lots of different ways to solve this. I'm going to use some mental math to figure it out. I know that 7,000 plus 2,000 is 9,000. And then I see that 800 and a 200, so that's another 1,000 to make 10,000. And 42 plus 10 is 52, so 10,000. 52. Could check my work using a standard algorithm if I wanted to. 0 plus 0 plus 0 plus 2 is 2. 0 plus 0 plus 1 plus 4 is 5. 0 plus 8 plus 2 is 10. And then you would carry that 1 over, and 7 plus 2 plus 1 is 10. So, yep, 10,052 is correct. So the answer to my whole problem, back to the start, 1,436 times 7 equals 10,052. And that's it.